Next comes the high voltage circuit build, and this is probably the hardest step of the entire build here. So you need to pay attention to this, and there are a couple of test steps we should do at the end. So the parts you'll need for this are two 22 picofarad capacitors. They've got 22 written on them. A 2.2 microfarads 400 volt capacitor, and you should be able to read that on them. Two 100 nanofarad decoupling capacitors, a UF4007, the other diode in the package, a 28 pin socket and the controller that goes in it, a 16 megahertz crystal with 16.00 written on it, 100 microhenry inductor, a 3K resistor, a 10K resistor, a 390K resistor and a 4.7K resistor. And we're going to go through the build of this a step at a time. So first of all we're going to put in the socket, and then you have to notice here on the socket there's a notch, on the controller there's a notch, and on the board there's also a notch written down there. So we have to put in the socket the same way as the notch says, and it can be a little fiddly to get in. If you just persist with it, it will turn out fine. Make sure you don't bend any of the legs, and make sure that all of the legs come through properly. And then what I'm going to do is I'm going to tape it down while I just tack the first couple of pins in there. So just waiting for the soldering iron to heat up a little bit, and then what we're going to do is we're going to put in the 22 picofarad capacitors C5 and C6 on the top, then the decoupling capacitors next to them, the crystal, and then we're going to go around building the rest of the boost circuit in here. So let's start at the beginning, and let's put in the socket first of all. And what I'm going to do is I'm just going to tack 2 pins, one on each side of the socket first of all. That holds it still while I take the tape off. And now I can go back and make sure that it's sitting down on the board properly, and to do that I put my finger on it, hold it in place and just reflow the joints, and that looks good. So what we can do now is we can zip down the rest of the connections in here, the other 26. Okay. Heat the pad up and then apply the solder to the pad. Make sure that the joint looks nice and bright and clean, and it's got a meniscus on it. That way you know that you've got a good joint. I tend to put in too little solder because this solder is a bit thin for my my habit. But it's just a simple job of going down the rest of the contacts here. Make sure you don't fill in any other contacts. So for the resistors here, by mistake, they're difficult to get clean afterwards if you fill them up by accident. So it takes a little bit of care. Those joints look quite nice. So that's the socket done. Let's go and fill in the rest of the clock circuit here. C5 and C6. I'm going to put them with the number on the outside so you can read it easily from the outside. That one's in the wrong way around. And C8, C7 and C8. C7 and C8. And again, I'm going to stick my bit of tape on the top to hold them in place while I solder them. And I'm going to solder just one pin of each of them, just to make sure they're in place. And we can take the tape off and make sure it looks right. And it does look right. So now we can do the other pins, the other side of each of the components. I move the board around a lot to make it easy. I don't like to be struggling when I'm doing this work, so I don't like to pin the board down because that makes it difficult to get into some of the corners. Some people like to put it on a frame to keep it all still, but I don't like to do that. Okay, so we're all trimmed up, very good. Let's put in the crystal. Doesn't matter which way around the crystal goes. Every time there's a polarized component, I'll tell you when you have to take care of it. Lots of these components aren't polarized. One. Tape off. That's a reasonable gap underneath it. Two. Trim up. So now we're going to do D2, the UF4007. Just bend the leads down and make sure the white stripe matches up with the white stripe on the board. Now we can put in C1, and again there's going to be a white stripe on the component and a white stripe on the board, and this goes the other way around to the previous two polarized electrolytic capacitors. Make sure when you have trimmings, make sure you get them well out of the way. It's so annoying when you get to the end of a build and then you suddenly find that you've put the PCB down on a bit of old wire and it's blown everything up. So now we're going to put R9 and R10 in. R9 and R10 live here, and they must go in the right way around. You must not get these the wrong way around. So 4.7K, that is yellow, violet, black, brown, brown, is R10. And R10 is the top one. Do not mix these up. If you mix these up, you will put high voltage straight into your controller and you will destroy it. Double check. So 4.7K in R10. So R9 has the color code orange, white, black, orange, brown. And this goes in the position of R9. Placing it so it looks good. That's a voltage divider which measures the high voltage. So the controller measures the high voltage many times a second and then adjusts the PWM to make sure we stay on target. R18, the 10K resistor, brown, black, orange. actually serves as a pull-up resistor for the reset line on the controller, and it goes over here. Value isn't very important, but 10k is the recommended value. This stops the controller resetting for no reason. Of course, that wouldn't be a good thing with a clock. Okay, and the last resistor is R7, which is a 3k resistor which serves, if I can find it, to pull down the gate on the MOSFET. Oh, of course I forgot the MOSFET, didn't I? I'll find that in a minute. Okay, the inductor, the 100 microhenry inductor L1 goes in there, and this needs a bit of tape to hold it down. I'm using the same bit of tape over and over again. Whenever I use the tape, I only do one pin because it doesn't hold it down tight, and then I reseat the component and then do the other pin. Okay, last component which we need to put in here is an IRF 840, which also might sometimes be an IRF 640. So this goes in the same way as the regulator, with the tab facing outwards. And the easiest way of doing it is just to rest it on the table so that they both have the same height. Be careful that they don't touch. The metal tabs mustn't touch each other. So I'm going to adjust that a bit to make them stay apart. The MOSFET may come wrapped in silver paper, in aluminium foil. Just give it a visual to make sure there's no bridges or there's no trouble on any of the components. Make sure your working area is clean and there are no offcuts on it. And then we can put in the controller and we can have a test. So for this, we're going to pull back in the power supply, which is set to 9 volts, and we're going to get the meter ready to measure the high voltage. Now at this point you want to be sure that nothing is going wrong, so listen for a crackling when it starts, and then we'll measure the voltage. Nothing should get hot and nothing should sound strained. A very faint crackling, that's a good sign. Now we can measure between here and here, and we have 180 point something volts. Perfect.